Hey, sixth grade. Today, lesson 6.5.1 is all about probabilities of compound events. In our last lesson, 6.4, it was about finding the sample space for multi-step event experiments. So you had to do both of these things. You had to spin both spinners. So it could have landed on white and 5. That was right. White and 5 is right there. Or it could have landed on B and 2. That was right there. Notice that each of these outcomes in these white areas here have two symbols. One is a letter, R, B, G, and W, and one is a number, because you have to do both spinners. All right, so for most of us, we thought this was pretty easy once we caught on to the pattern. Now we're going to use the sample space. We're going to use just that sample space to find the probability of a specific event. So the very first one says, P, the probability of both red and odd. I'm going to go back into my chart and find the red. So that's just this column, but now I just want the odd numbers. So there's red 1, red 3, red 5. It looks like it's 3. So for a fraction, it would be 3 on top of, and now I need to figure out how many total outcomes there are. I can count each individual one, or I can say it's 5 tall, and it's 1, 2, 3, 4 wide. So 5 times 4 is 20. So the fraction is 3/20. There are no common factors. So in my calculator, 3 divided by 20 gets me to 0 and 1500ths, which by now you know equals 15%. All right. So the next one says blue, and then that symbol that sometimes people don't remember what it means. So what I like to do is pick a number that would make sense to go right there. A lot of people know that the mouth eats the bigger number, right? So I could put like a 5 there, and then I'm just going to think, is 5 bigger than 3 or less than 3? It's bigger than 3, it's greater than. So this time we're looking for a combination of a blue and greater than 3. So here we go. Blue is all in this column. We just want the ones that are also greater than 3. So there's 4 and 5. That means it's 2. But because it's the same sample space, I can use the same denominator. So there's 2/20, which is 1/10. Some of you just know that looks like 0 and 1. But if you don't, 1 divided by 10, right? And if you want that to be a percent, then put in an extra 0 and see that it's 10%. You really want 2 decimal digits, right? And then for the last one, it says the probability of not green and 2. So this time I'm going to find the column that is 2. It has to have a 2 in it, but we do not include green. So I'm going to cross that one out. So it looks like there's 1, 2, 3 of them. So for this probability, it's 3 out of 20. Hey, that's the same. Oh, whoa, sorry. That's the same as the first one. So 0 and 1500ths and 15%. Not too bad. The part that's tricky about this is that you have to actually make this sample space. So is there a shortcut where you can figure out the probabilities without making the sample space? Why, yes, of course there is. And it has to do with knowing these times things, right? So here's what I mean. There are 4 outcomes on spinner number 1, and there are 5 outcomes on spinner number 2. That means that there are 20 outcomes. But even more importantly, we're going to look at the probability of each individual event on each spinner. All right, so here's what I mean. The probability first of red. There are 4 parts, and just this one is red. So the probability of just getting red is 1/4. And then look at the other spinner. What about the odd numbers? There's 1, 2, 3 out of 5. So that's 3/5. And I'm going to times them together. Ms. Toivola, why are we timesing them together? Well, there's a few different reasons. Number 1, we know there should be 20 outcomes, and 4 times 5 is 20. And the top number, 1 times 3 is 3. Hey, that looks familiar. If we go back and we look at our actual sample space, I want you to notice that red in the sample space is 1/4. So here is the red column. That is 1 out of 2, 3, 4. Do you see that red is 1/4? Cool. Then going the other direction in our rows, we need the odd numbers. So here are the odd numbers, 3 and 1 and 5. Do you see that that's 3 out of the 5 options? So that's 3/5. So we're really looking for where they intersect, right? So where they intersect is the one red column and the 3 rows. So where those cross, that's where our answers are. So that's why it's 1/4 times 3/5. All right, Mr. Toivola, prove it. Let's look at another example. Okay, for the next one, it says blue. So this is 1/4 blue. And it says greater than 3, so that's 4 and 5. So that's 2 out of 5, which means the next one should be 1/4 times 2/5. 1 times 2 is 2, 4 times 5 is 20. Simplify to 1/10. That looks familiar too. Here it is, right there. All right, which means the last one should be 3/20. Let's check it out. On spinner number 1, we do not want green. Cross it out, and you'll see that there are 1, 2, 3 left. So I'm going to write 3/4 times. And for spinner number 2, we just want the number 2. So there's one of those times 1/5 equals 3/20. Yep, that's the same too. All right, cool, Ms. Toivola. Which method should I use? Well, it's the one that you understand the best. If you don't understand where these fractions come from, then don't even bother trying. Make the sample space. Figure out how many options there are, and then look for those events. Look for both red and odd, blue and greater than 3. Okay, Ms. Toivola, that makes sense, but what about probability trees? I'm glad you asked. Here's the probability tree for the bikes. I can see that there are 1, 2, 3, 4, 5, 6, 7, 8 outcomes. So for every single one of these, I'm going to write 8 as my denominator. The last one, 8. Now I just look at the outcomes to try to find that exact event. First, we need large and blue. Here it is. But if I look through all the rest of them, there aren't any others, which means this one is 1/8. I'll go back and change decimals and percents, but I feel like a lot of you are really figuring that out. For the next one, medium, any color. Well, this one's medium and red, that's a color. Medium and blue, that's a color. Medium and black, that's a color. Medium and purple, that's a color. That looks like 4. 1, 2, 3, 4. So that's 4/8. This one's really easy. That's 1/2. That's 50%. Right? And then the last one says the probability of not purple. So I'm just going to cross out the ones that are not purple. This one down here on the bottom has purple in it. Don't count it. This one here on the bottom has purple in it. Don't count it. But none of the rest of them have purple. So we can count all of those. There's 6. Here we go. 6/8. This is 3/4. I know this is 0 and 75/100, like 3/4, which means it's 75%. And then this first one, 1/8, really quickly, 1 divided by 8. Some of you are just starting to recognize that too. 0 and 125/100. But we really just need the first 2 for our percent. So that's 12%. You could throw in the 0.5, but it's 12%. All right, Ms. Toivola, I can do this. I don't really want to draw out the trees. You don't have to if you remember that shortcut, because it works for these problems too. Here we go. It's a little bit different though, right? You really have to think this through. How many options did the person have when they picked large? They had 2. Large was 1 out of 2 options. That's 1/2. Now be careful with the next one. What about blue? There are 4 options: red, blue, black, and purple. Out of those 4, how many are blue? 1. So that means this is going to be 1/2 times 1/4. We just got this answer. That's 1/8, or 12.5%. Right? What about for medium, any color? Well, if large is 1 out of 2, then medium, there were 2 sizes. Medium was 1 out of 2, and any color. That means you can choose all of them, but individually. Red counts, blue counts, black counts, purple counts. All 4. 4 out of 4 options. Multiply across, 4 and 8, that's 1/2. There's our 50%. All right, the last one, not purple. Well, if it's not purple, then we don't really care about the size. So you can use either one, large or medium. So that's 2 out of 2. Right? You can use both of those options, times. And then if it's not purple, then we cross out the purple one. And it looks like there's 1, 2, 3 left. So that's times 3/4. That gets us 2 times 3 is 6, 2 times 4 is 8. There is 3/4 as a final answer, which is 75%. All of those match here. Ms. Toivola, which one should I do? Do the one that makes more sense for you. The shortcut is nice, but if it's just magic numbers, then the likelihood that you just pick those right numbers is pretty low. But these aren't too bad if you actually have the sample space.